We are going to try and do some data curation. I'm here at our Wolfram Summer School with a bunch of talented people who hopefully are going to help me when I get stuck, which I undoubtedly will. The objective here is to try to take some data sets and try and get them in a form where we can have them suitable for upload to our data repository here. And then typical things in the data repository would be something like, well, let's take this, I don't know, public housing developments in 2015. We will see something here that gives us a curated version of a data set that's been cleaned up so that it's easy to start computing with it. So we have a list of candidate data sets here, and I think the one we just picked out was locations of patent awardees. So we'll go to the website where this data set is available and start taking a look, and first of all try to get the data set ready to download. And okay, this is looks like a lovely place where we've gotten to the 0th level of data curation, which is the data set is somehow available. Let's see what happens. Historical data set, data. Let's press the download button, see what happens here. Original file, comma separated values. Okay. Well, let's take original file, comma separated values, see what it does. Okay, 165 megabytes. Let's load that in and let's get ready to read it. We should be able to just read that straight in. Famous last words. Data curation, nothing ever actually works as easily as you expect. Okay, so we're in the downloads folder there. So now what we're going to do, let's minimize this. Let's go here. And now, let's say import, and we're going to go to the downloads folder. We're going to insert file path and go to the downloads folder. Where is it? Help. histpat.csv. There we go. Choose that. Okay. So let's call this raw data and let's see what we get. See whether we can download this. And let's start naming this something here. Let's see, what am I doing here? I'm going to put this under data curation and let us call this patent locations 01, and it's still loading. That may not be a good sign. Let's just see. Or it may just be that this is a slightly slow computer. All right. So what we should be getting here, I've no idea what structure this data has. So let's just see whether we can at least load it in. I think it might be a good idea to just take a little look. Let me not try and load this in Excel because I'm sure that it will break there. Let's say, oh, there we go, it loaded in. Okay, so let's say, what's the length of raw data? Okay, 3.5 million rows of data. So let's say we say take raw data, comma 5 or something for the first 5 rows. Okay, so what we've got there looks like the very first row of the data set tells us the structure. It's a PN. I have no idea what a PN is. Alpha and a year. Okay, so when in doubt, we might actually try looking at the data source and see whether it has something which explains what the things are. Let me see. Well, in this download here, I wonder whether it has something which claims to say, okay, data subset variable metadata. How about that? Maybe variable metadata is something useful here. Let's take a look. Okay, so what did it just download here? It downloaded histpat.xml. Okay, oh my gosh. The XML file is opening in Microsoft Word, and it says that there's an error. Okay, and Word is going bonkers, and let's ignore that. Okay, let us try loading the XML file into Wolfram Language and see whether we have better luck there. Okay, so let's take that XML file. Okay, so what we have here, I mean, let's see whether we can import the XML file. XML metadata, and now let's try and do an import, and let's get here, let's do an insert file path. That was from downloads. There should be a .xml file here, histpat.xml, there we go. Choose that. Okay, so let's try and import the XML. Magnificent. Okay, well, at least it imported as something. Now let's figure out how on earth we'd make any sense out of this XML structure here. Anybody got any brilliant ideas? Okay. The suggestion is, okay, so XML data, cases, what are you suggesting? So,
just write a pattern for whatever you want and set up a section.
yeah, but what do we want? I mean, so name, oh, okay, so here, look, we've got, it says here, okay, so, no, but this is saying, okay, universal numeric fingerprint. Universal numeric fingerprint. That's what that is. So we've got this subject arrow, whatever. So let's see what those look like. Let's see what the subject arrow blank. Yeah.
I downloaded the guidelines.rtf file and it defines the first few.
Oh, okay. All right. Let's okay, that sounds good. So wait a minute. Third element here is infinity. Let's just try this. Oh, maybe everything has a universal numeric fingerprint. That may be some kind of, let's try the name field here. That's just telling us the exact same thing we already know. Okay, let's take a look. So someone's suggesting here, what was it called? Which now what? How do you download this? You hit the download button. Okay. Magnificent. Okay, so here we go. So this actually is telling us something here. So this now, I'll make it much bigger. Yeah. Okay, here we go. Let me just, we could import this actually, but I'm just going to copy paste it. Okay, PN is the patent document publication number for patents prior to 1836. It's USX. So that might be. So that's probably the patent number. So FIPS is the FIPS code. That's part of the Census Bureau. The way the Census Bureau divides up the country. State, we probably know what that is. County, we know what that is. Okay, so this is a source thing. Expected accuracy for automatically inputted locations. Okay, I see. So this is an error rate. Okay. Patent document publication year as shown in patent documents. Okay. Oh, I see. So this is a way of encoding the actual patent. All right. So let's go ahead and we can start pulling these apart now. So now, okay. So this thing here isn't particularly useful. This XML thing. So now we've got. So in raw data, the top element we can just strip off because we don't. What we want to do is to take this raw data, and we want to take each row of the raw data and turn it into something meaningful. Okay, so let's take. Okay, so that second row, what we're learning is the last thing there should be an interpreter. Let's just check that's going to work. And actually, we don't even need an interpreter there. So each one of these things, that last element, so let's try writing a converter. And the converter is going to take lots of different elements here. So it's going to take, the first element is the patent number, the second element is the FIPS code, third element is the state, the fourth element is the county, fifth element is source, alpha, whatever that means, and year. Okay, so now this is going to be starting to turn this into something meaningful, right? So I think we're going to have certainly a thing that says year. Actually, we could say year arrow, and then that's going to be a data object that has the to expression of that year, I claim, is going to be the that particular part. So if I say converter, that should convert. If I say this is a converter onto rest of take raw data, comma 5. Okay, great. So those are now canonical year specifications for the years. That was the easiest part. Now let's see whether we can start doing something a little bit harder. Let's do the state designations here. So the state designation, we should be taking something like, so we should say interpreter, and then we'll say US state, and then let's try MA, see if that works. Massachusetts, US, that looks good. So now, what about ones where the patent is from outside the US? That seems, let's just take the end of the raw data. Let's take the last 10 elements, more recent things. Wow, how come, but many US patents don't have inventors who are based in the US. So what is it going to do when there's something which isn't based within the US? I'll tell you what, let's do this. Let's take the third element here of, let's take raw data, well, let's say, let's call data, no, let's say X raw data is rest of raw data, so that we don't have that header line which is trying to define it at the top. So let's now say, let's take X raw data, and let's take all of those, comma 3, and then let's count those. And then that should give us a count of, come on, wake up. That should give us a count of all the, there we go. That's a count of all the states, right? So that's showing us, so what that shows us is that every patent here is allocated to some US state, which is kind of weird. Doesn't seem right to me. But anyway, we can, at the very least, let's start off doing something. From this result here, we can already get something slightly interesting, although it's not the curation that we want to do, because we can basically say, for each of these things, we want to do a key map onto the keys of interpreter, US state, let's see, onto line 14, that's that line there, and hopefully, I don't know why this is so slow, it's having to, and then hopefully what we should be able to do is a geo, there we go, okay, so that's showing for each US state how many patents were in that state. So let's say geo region value plot of that, and if we're lucky, we should be able to get, wake up, there we go, oh, that's pretty cool. So that's showing us the density, wow, that's kind of interesting. That's showing us the density of the number of patents by state. And probably if we wanted to, we could divide by the population of each state. Let's just do that just for the hell of it. And then this will be good as an example of this data set to get this result. Okay, so now let's see, we want to get for every US state, we want to get the population of the US state. So we want to say US states, and then we just want to say, we might not want District of Columbia here, but let's say entity list. That will get us a list of US states. And now I think we want to say association map, is that right? Let's see, we want to say hash of population, I believe.
Also, if you want to make it run much faster, say entity value of the original entity class, population, association.
Good idea. Entity value of this, comma, population, comma, entity association, right? Oh, the entity class up at the top. Yeah, that's a good idea. Okay. Okay. Entity class there. Well, let's try giving it the entity list here. Nope. That's really weird. Well, anyway, we can easily deal with this. Okay, so there's the list of...
Just say, the annotation at the end is important. But I think we just have it wrong. Annotation. Actually, you should be able to do entity association.
There we go. Just association there. Okay, so that gives us that. We now want to probably delete district of, well, then we should be able to just take this result on line 15 there and just divide by this result here, by line 15 divided by line 21, I hope. Now this might not work because of District of Columbia. No, okay, so let's remove, let's see, we want to, yeah, okay, we want to do, that's right, we want to say key intersection of line 15 and line, why is that complaining? Key intersection, line 15, line 21. Is that right? That's not right. How do we deal with this? Key intersection. Oh no, this is right. This is right. This will give us the right thing. So now we just want to say apply divide to this. Okay, there we go. So now we've got, albeit in these kind of crazy rational units, so let's just do an n of that. Oops, I just want to say n of this. Okay, there we go. So this is the number of patents over this period of 200 years per person in each state. And so now we can do geo region value plot of that. And there we go. That's kind of interesting. Okay, so the Northeast, the Midwest seem to be the winning states in patents per head of current population. Now it may be a little bit unfair because California had, was only populated in the more recent years. But let's go back now and continue cleaning up our data. Okay, so let's write this. So, yeah. Okay, so what do I do?
Just make this not slightly smaller.
Which way?
Leaving it in the corner. The top corner is fine. The top left corner is fine. So from the bottom right.
Oh, bottom right here.
Yeah,
Like this?
A bit narrower.
Like that?
More, a lot more.
Narrower? Like this?
Yes, getting a bit better. If you can do more, it's even better.
Well, the more we do, the less we'll be able to see. Okay. All right. So now our goal here is to take, by the way, this is a little weird that the last year here is 1918. So I'm a little suspicious about this. So I would like to take our result here from the converter. Let me see. So we could just take, well, let's do let's apply the converter. Did we apply the converter to the whole data set? X raw data. No. Okay. So we want to say here. Okay. So experiments on the data was down here. So now here we're going to apply the converter to the whole of X raw data. And what we'll get to begin with, let's call that data, and to begin with all we're going to get is just that thing with years. And then what we could do then is to take, okay, it's taking a while because there's 3.5 million of these things, but let's, so now we want to take all that data and say all comma year, I think, and that should give us just the years. And then we could say date histogram of that, and then we should be able to see what I'm a little bit suspicious. Oh, there we go. I think all comma year will do the right thing, right? We've got an association, yeah?
Well, yeah, by the date it's going to be really slow with lots and lots of data. So how many do you have?
3.5 million.
A lot.
Okay, well, I'll tell you what, we can, all right, yeah, okay, so let's say, let's do a random sample of, let's say, 5,000 of these things. It's not a data set. It's not a data set. It's just a list. Oh, no, you're right. We cannot. Okay, all goofed up here. All right, so let's take random sample of the data. Let's take 5,000. So let's take sample 5,000 equals this. And now we can say sample 5,000. And then we should be able to say all comma year. There we go. And now that should work. Now we should be able to say date histogram of that. There we go. Okay, so that's showing the number of patents in our random sample per year as a function of time, okay, which is somewhat promising. Yeah, it's okay. This shows us roughly the growth, so this is okay. So let's continue cleaning up the data, okay? So let's say, so here we've got, that's our random sample. Let's move this down to our experiments section. Experiments on the data, and let's say this is here, let's call that years, and let's call this thing here states. Okay, so let's clean up the states part of the thing next. So that's the third element. So now we're writing our converter here, and we say year, and we're also going to say, let's call it state, and then that's going to be, I think, the fastest way to do this. We could use an interpreter. Well, I don't see why that shouldn't work. I wonder whether it will cache the results. We can just say, we can just have a thing called state mapping, which is for all the states, which is that thing that we had done someplace down here. We've got all the states. Here we go. Okay. For the state mapping, we want to say, actually what we want is the collection down here of all of those abbreviations. So we just want the keys from here. So if we just say keys of line 14, then that will give us all of the keys that are used in the data. So actually what we want to do, I'll tell you what we want to do. We want to take the data, yeah, this is going to be fine. We just take these keys here, and for each of those keys we're going to say map that to interpreter US state of the thing, okay? And so then this should give, well, we only have to do this once. We only have to do this once. We're only doing this one time for all the states. Oh, yeah, you guys are right. Okay. Anyway, that gives us our mapping. So now we can just say this here is replace of state, comma, state mapping. Okay. So let's continue with our converter. Okay, there we go. So that's a sample of what the data is going to look like after conversion for those. Okay, so now let's go back and take a look at what else is. Okay, this is a big, complicated, messy thing here. Let's close that up. Okay, so now let's look at what the next thing is. So the next thing is a county. So that's going to be a little tricky because that's a county in a state. So we want to give, okay. Yeah, so we use, okay. So let's take, for each county, so this is, let's make this simpler because it's going to be, anyway, it's going to take a while to run for the whole data set anyway. So let's make this the way it should be. Let's just say this is interpreter.
That would be unbelievably, that would be thousands of times slower.
Yeah. All right. Well, it shouldn't be because it's supposed to get cached. So, okay, all right, we'll leave it as this. Okay, so then we're going to want to define a county mapping. So for that, we need to get each one needs to be its, so we extract the county. So let's take a look at what the counties are here. So it's going to be, so let's take an example of one of these. So let's say interpreter, I don't know whether we have a US county. Yes, we do. Okay, US county there. Okay, so then this will be basically the join. So we'll say Middlesex, comma, MA. So what we want to do is we want to say, essentially, well, let's just type this one in.
I think you can also use restricted, except it might be slightly slower.
Well, let's try doing this, okay?
Actually, the reason not to use restricted would be that you can't do it in a single interpreter call. What you
Right.
can do is you can have lots of counties you want to do all at once. Then
Okay, well, this is a bad sign. Let's say Middlesex, comma, MA is not found. Okay. Let's take a look at the documentation for US counties. And this is a new version, so that's why it has that weird, okay, Orange County. Well, that's really strange.
run the example to see if it works.
I've got an idea here. It's kind of grotesque, but I think that's going to work. Let's see what happens if I say Middlesex County, comma, MA. Yes, it works. Okay, so that's a little grotesque, and it probably shouldn't be that way, and that's probably a bug that in the county interpreter. But let's try now writing code here that says, so what we're going to do is we're going to use a string template, which is going to give the name of the county, followed by the word county, followed by a comma, followed by the name of the state. And that, I'm sure it does not, but let's see if it cares about capitalization. No. Okay, so let's say that's a string template. And that, I think you can just apply that, if I'm not mistaken. Come on, apply that to a list.
You want to apply that just not without the list, but otherwise it's
Okay, great. All right, so then this string template, apply the string template, and now I suppose we should try to get out a table of all of the counties that occur in this thing. Let's at least get a table of the counties in the sample. Well, ultimately, yeah, I mean, ultimately it's probably going to be,
well, you can try to take the union of all the counties that appear, and it would be less than 3 million.
yeah, right. So, okay, so let's take, here what we want to do is to say all counties is x raw data sub all comma 4. That will give the county designator. But that's not good enough because we actually have to have the county and the state for each thing. So what we want is all comma 4 comma 3, and so that will give the 4-3 element there. So that's going to be all counties. And now what we want to do is we want to say union of all of those, and that should give us all the counties in this data set. And let's now say take that, comma 10, and see what that. Yeah. Okay. Let's say. Okay, so that's that there. Okay. Well, I think there are about 4,000 counties in the U.S. So that means of the 4,000 counties, 3,148 of them have patentee, have people who. Okay, so now let's take all counties, comma 5, for example. Okay, so great. So now let's use our string template thingy to apply the string template. So we'll take that and we'll say apply the string template to that. Okay, and now let's say interpreter of US county, and then I want to say comma of this, don't I? Of that. I want to apply that US county interpreter to the list of counties. Okay, interesting. Okay, so Acadia County, LA does not, well, it says it isn't available, which is really weird. Oh, that time it worked. Okay, fine. All right, so now we're going to get a list here of, this should give us, so we got 3,000 of these to do, which might take a little while. But this is going to give us for each one, it's going to give us the county. So let's go ahead and, unfortunately it's going to take us a little while to do this, but let's go ahead and start this off. We could, if we wanted to, we could actually run this on a separate thread. Let's run it, or we could actually submit this to the cloud to run. Let me see if that works. So if I say cloud, well, I'd have to have some callback function then. Let's see what happens if I say cloud evaluate of this thing here. I'm not sure it's going to take the definition of all counties with it to do that in the cloud. Let's see. Oh, no, it worked fine. Okay, so that was running in the cloud. So that was running a separate, that ran, we could also run it in a separate kernel on this machine, just so that we can do it in parallel to see what's happening there. Let me see. So, okay, so that ran in the cloud and actually ran nice and fast in the cloud. So I wonder if we want to live really dangerously. And, okay, so what we're ultimately going to want is something where we take this thing applied to, we want that thing applied to that, and we want this arrow that, and that's going to make us our map that over, take all counties, comma 4 or something, and then we want to say, oops, we want to say that. No, what went wrong here? String template, interpreter of the string template applied to that thing. Okay, oops. Okay, there we go. So that's what that should generate. So if we want to live slightly dangerously, we can try doing this. Let's try doing it for a slightly larger chunk. See what happens. Maybe this idea of running it in the cloud isn't so hot. But we can also just run this in the background and have it do the conversion in the background while we work on some other parts of this. It really would be good if this did caching better. Oh, there we go. Okay, so, all right, so this is our first 50. We've got 3,000 of these to do. So, oops. That's bad. Oh, shoot. That's DC. And we removed DC from, but is that even correct? What is Alexandria, DC? That doesn't make any sense. That was the county of, does anybody know, does DC have counties? Anybody know? Any Americans here? No, but Alexandria, DC. Great. Okay. So, all right. So, okay. So we're going to have a little bit of messiness here because we're going to have some counties that don't exist. I mean, we're going to have some things in the original data that don't exist. So we're going to have to decide what we're going to do with those. Like Alexandria, DC. Is there any subpart of DC that's called Alexandria? Or is this just completely goofed up? I know, but that's the next one. The very next one is Alexandria, Virginia, which is, okay.
There's something called Alexandria County, DC.
Oh, really? Well, so why don't we know about that? Let's try,
Well, but it seems like it's sort of has weird.
it's some weird thing. Okay, so let's try getting, okay, first thing is let's try spawning this off. Let me see if I can create a separate kernel to do this. Let me see how to do this. Notebooks kernel, I haven't done this in such a long time. Start kernel. How do you create a kernel?
You first create a new kernel and then you switch that.
Where's the create new kernel?
You need to say kernel configuration option and set up local 2, which is like the default thing.
Oh, but why is kernel configuration options grayed out?
Oh.
Well, if I say humph, all right, well, if I say cloud submit, what will happen if I say cloud submit 2 + 2 or something? It'll come back with a cloud object. Now, if I go to that cloud object, it will hopefully say, okay, there's the output, but now how do I get it to send me? If I go to the cloud submit, how do I get it to take the output and send it back to me? Actually, I wonder, this version might have local submit. Ah, this is encouraging. That's not encouraging. That's lovely, but not relevant. Okay, let's look at cloud submit and see whether we can use this to submit it as an asynchronous job to the cloud and then have it run that in the background while we work on some other stuff. So cloud submit, notification function, submits it for immediate asynchronous evaluation. So one thing we could do is we could simply have it save the result in a cloud object, and then we could read the cloud object back in again. So let's test that out. So we could say cloud put of this to a cloud put of 2 + 2. Let me just check I've got this the right way around. Cloud put 2 + 2. You know, this is something goofy. Why is that? I think this is a bug in the version that I'm using here, because it's putting the little indicator that lets me look for information. It's putting that away from. So how about somebody here, like John here, reports that bug, that this thing is in the wrong place when it's magnified like this. And if I go here, see the indicator is in the wrong place. Okay. All right. So let's say temp output 1. Let's say, let's do this. Okay. There we go. Ah, right. So now what I want to say is cloud submit of cloud put of temp output 1. Okay. So now if I say cloud get of temp output 1, let's see whether I get a 4. Yes, very good. Okay, so I'm going to send this then. We can cloud submit this thing to do the computation, okay? So what I want to do then is to say cloud submit, where was it? Where was the thing I was trying to do? Here we go. So I can go ahead and say this thing here, so instead of saying cloud submit there, I can say now cloud submit. Okay, so that was our first example. So now let's copy that down, and then let's say cloud submit of cloud put of this thing, comma, oops, where is that? No, there's the cloud put, comma, counties temp. That's the cloud put. Now there's the cloud submit. So let's go ahead and do this. So now we're going to, okay, so let's start this off running. Okay, so now that's happily running asynchronously in the cloud. And if I put a notification function in there, it would have told me what was going on. As it is, I can see, okay, so there it is. That's the evaluation started, 1640 GMT minus 4, so that looks good. So that's just the status page. Okay. I have to say, it would be good if this status page was more computable. That's something we should make that work. Maybe there's a way to do that. Okay. All right. So let's keep going here. So now that's going to make the mapping table for the counties, and there'll be some glitches, but now let's keep going, and we want to say, what were the other things here? So the first thing is this strange number here, which appears to be a patent number, and then there's this collection method, and then there's a FIPS. Let's look at the FIPS thing. So FIPS, let's see whether we actually have a FIPS interpreter. I think we may have. So let's see, interpreter. We do not. Okay, so let's see how we can get, I wonder whether there's a name for FIPS codes. I think we do have the notion of FIPS codes, so let's just take a look and see whether there's something related to that which we can find in the index. Zip code data, aha. Okay, so let's see, this is zip code data, and this is now, I wonder what is the relationship between a FIPS code and a zip code? Anybody know? Maybe we can look that up. Oh, there's a FIPS code for a zip code that's here. Okay, so a zip code seems to have a FIPS code. So let's try, okay, so let's say we say zip code 01742. So how do we figure out what FIPS code? So how do we get a mapping from FIPS codes to anything else?
Well, the FIPS codes don't map. The FIPS, it's like if you just had, where are the forests and you had where are the towns. They're just completely, they seem like they're just totally independent.
From zip codes. Yeah, I think they are. They're Census Bureau. FIPS codes are Census Bureau codes. But I don't know where the FIPS, so.
It says that they uniquely identify counties and county equivalents. So they're all counties.
Well, let's find out. See whether we know how to interpret that. Interesting. Missing data not available. No, FIPS code exists there. So FIPS code 2, well, let's find out what FIPS codes are in the data here. So X raw data, and let's say all comma 2, and that will give us all the FIPS codes. That was very fast. Okay, so let's say, now what we want to do, probably, we could say counts of all FIPS. Okay, so that's now going to go through. Okay, so there we go. So there are about 3,000. Oh, that's very suspicious. There are almost exactly the same number of these as there are of counties. So let's look at the length of this. 3141. How many counties were there? All counties 3148. Okay, so they're about the same number of FIPS codes as county codes. So now let's find out whether we can find somewhere on the web a mapping from FIPS codes. Is there a mapping from FIPS codes to county codes, or are FIPS codes? FIPS codes may have been defined at a different time in history. Anybody get? Let's just see. Let me just see what's happening to our job here. Still says evaluation started. Okay, so let's look up FIPS codes. FIPS codes for counties. FIPS code files for counties. Okay, 2010. Oh, they may have been for counties and county equivalent entities. Lovely. Okay, so it appears to be the case. Select a file. Let's see. So we want for United States, and let's say go here. Slightly suspicious that it said pop-up was blocked. Select. For which records of the form, okay, so state FIPS code and county FIPS code 011. So maybe these are concatenated. Maybe there's a state code.
The first 2 digits of FIPS code of the state and the last 3 are the county.
Ah, okay, so these are, okay, so fine. So these FIPS codes, so if we take, so we really have to break this up into a state and county piece. So the FIPS code is really, so let's go ahead here and, so each one of these, like FIPS decompose of something like 2502 of a number is otherwise known as integer digits of the number, comma 5, just to check we got the right thing. And then let's say take drop, comma 2. Okay, so that should be able to decompose the FIPS code. Decompose 25025. What the heck? Oh, very silly. That's a base 5. We decomposed it in base 5. Okay, there we go. 25025. Okay, so now we want to probably go through those, and we want to say from digits that, comma 10, like that. And so that will now be, oh, do you think it matters that there's a leading 0 in the second FIPS code? I mean, it may matter that these are. Right, but do you think there's a separate 1, or do you think it's just 1? I think it's probably just 1. I think we can assume it's just 1. Okay, so that decomposes the FIPS code. So now let's find out if we do that, if we do keys of all FIPS, and now we say FIPS decompose, mapped over that, then that will give us the, that should give us, oh my gosh, All FIPS was up here, right? Oh, it's the counts. I want counts of all FIPS of line 63. So that wasn't encouraging. Okay, keys of line 63. Oh, no, I know what I want to do. I need to say to expression. I need to convert all those things to actual numbers. Okay, super confusing here. All right, let's go back. Let's go back. Let's get this right. Okay, so keys of line 63 is a bunch of FIPS codes which are strings, I think. So if I take...
You saw the error though, it looked like there was some that had decimals.
Lovely. Okay, so those are...
We tried just mapping head over it.
Oh, they're integers. They are actually integers. Oh, yeah, okay, fine. Okay, so let's do head mapped over keys of head mapped over this, and then let's say counts of that, and let's see if there's something crazy that happened here. Oh my gosh, there are 15 FIPS codes that aren't FIPS codes. Unless there are FIPS codes with decimals in them. Let's find out. Okay, so let's find cases in keys of six. So remember, what must have happened here is that the converter that read in the CSV file was trying to be very clever, and it was trying to, okay.
Well, what you should do is you should find out which row those are seated in the CSV file. If it's got a decimal in the CSV file, then it's not your fault.
Yeah, right. Okay, so these are the keys. These are the FIPS codes, the supposed FIPS codes that read in as decimals. Okay, so now let's say X raw data, and then what we want to do is we want to say position in X raw data of, let's take the first one of these guys. My, oh my, oh my. Okay, so there are a whole bunch of lines. Okay, so let's take the first such line in X raw data. 3, 4, okay, so let's say, yeah, I will, but 3, 4, 5, X raw data of, take that, comma 5, for example. Let's just look at the first, let's say column, just to display them like that. Okay, those are District of Columbia things. Okay, so let's find out whether all, so can somebody look up whether FIPS codes work differently in District of Columbia? Let's try one of the other funky FIPS codes, okay? Let's try this one here, okay? And let's say,
According to the National Weather Service, the District of Columbia only has one FIPS code.
okay. Okay, so yes, that's possible. So, but they aren't the same prefix. These FIPS codes aren't the same prefix here. Oh, they're mostly 2900. Okay, so look, let's be organized here. Let's find out what these actually are. Okay, so for each one of those weird FIPS codes, we need to figure out where it is. So, yeah, I don't know what program to open the thing in. It's the thing is a pretty big file. What should I open it in? Okay. I wonder what text editor is on this machine. All right, let's try text edit. This looks unpromising because it's going to try and format it in some weird way. Okay, so let's go to downloads and let's open, what was this thing called? histpat.csv. Oh, you're right. It did open nice and fast. Yep. And then, okay, so let's go look for that FIPS, the funky FIPS code. 11001.2. Yep, there it is, District of Columbia. Command plus? No, I'm sorry. That. Okay. Well, anyway, okay. So it seems to be in the original data. Okay. So there are a bunch of funky FIPS codes that have decimals in them. Well, that's a question. I mean, okay. So let's find out if they're all District of Columbia. Let's at least figure that out. So each one of those. Let's take each one and take the first position.
By the way, that is the FIPS code. 11001 is the FIPS code of PC.
Well, but what's 2900? That's the FIPS code of something else. What's that?
29, anything with 29, 29, something is from Missouri.
Okay, so there's something wrong. The Missouri doesn't have the same issue. Well, let's look in here, 2900.4. Is Yukon Konya. What the heck is that? What's that?
Yeah, so that's a 02.
What's a 02? What?
So that 2900 is actually 2900, and 02 is the state code, which is Arkansas.
Ah.
Oh no, 02
No, but
is Alaska. Oh no, AK is, yeah, no, AK is. No.
Let's be very basic here. Is AK is Alaska. Yes, it's Alaska, right. So that's a place in Alaska. Yukon is a place in Alaska. Why does it have a decimal FIPS code? Is there enough information on the web about what?
It's 2900.
But for some reason they added a .4.
Well, I don't think that there are 00 zip codes.
No, this is a 09. This should be an 02900 because it's actually Alaska.
No, but what I mean is, oh, so it's 9, it's actually 9, yeah.
It's 900. And then, but let's take a look at what these places are, okay? So first position, let's just take a sample of each one. What's that?
Sorry, I'm looking at the census.gov, and there is no 02, comma 96.
I'm looking on the National Membership System. There is a 029.
There is a 02, comma 290, which is this Yukon Koyukuk
Yeah.
census area.
So there's an 022900. So that one there, the line here that says 2900.4, what do you think that should be? You think that should be 29004. Why don't we look up that patent? Let's go to the source and find out what's going on. Okay, so let's see. They do. They say where they're from. Okay, U.S. patent. It's a lubricating composition. Okay. Original assignee Shell Development Company. Let's see. Okay, so this is, let's go look at the PDF. Well, what the heck? This patent here, if it's really this patent. What's that? Okay. Well, is it the right patent? Okay, so this is 29257,994, but was that the patent number? No, that was 942. So something searched the wrong thing. Yeah, they should be the same. This is the US patent number. So this is, okay, so that's that. And then let's, well, there we go. There we go. Okay, by the way, we should also actually, when we do this, we should have a link. We we should put in when we curate this data set, we should have something which actually links. Let's just make a note of that. Oh my gosh, where do we go here? Maybe. Okay, so anyway, so this is J.I.E. Nelson's Concentrator and Amalgamator from 1909. And the question is, wow, application filled out. So this should be, so where do we go? Oh, maybe we have, yeah, so maybe we have to remove that.
Oh, because you're on slash pages slash.
That was -1. That was the figure. Okay, so let's go back.
If you go to Google Scholar, you can find the actual page about it.
Okay, so there's, okay, let's go to patents. What is it called? Patent.
Google Scholar. It's the same thing.
That was very weird. I don't know what I'm doing.
What is it? Man 0 or something.
You can just search the patent number there.
I think I can too.
Well, we tried to do that.
Okay, let's do US and then this. Okay, concentrator and amalgamator. Here we go. Okay, so there's the information on this guy. To whom it may concern, John I.E. Nelson, a citizen. Here we go. A citizen of the United States and a resident of Beatles Koyukok mining district in the district of Alaska, because Alaska wasn't a state at that point, have invented a new and improved concentrator and amalgamator. Okay, so what does this mean? So why? Okay, so it really is correct that this was from Koyukok mining district in Alaska. But now why would it have a FIPS code that has a decimal number in it? And is the correct FIPS code for Alaska that thing? So let's take a look here. Let's go back to what we were doing before, where we were trying to find which are the... Okay, so let's close these up. So close that up as well. Okay, so then this is the raw data. So this is now, let's go first slash at that. Oops. Okay, so those are the line numbers of, so now X raw data of % / column. This will show us, okay, this will show us the bizarre places that are the samples, at least, of places that have those weird FIPS codes. Now, okay, so is the FIPS code 2900, is that the FIPS code of the, well, let's take a look at that place there, okay? And let's go to Wolfram Alpha, which should be the home page here. Why isn't this loaded?
So Yukon has a FIPS code of 02290. There's a book, Population of States and Counties of the United States, and it shows all the FIPS codes. Most of the ones with the dots are ones that don't exist anymore. But they are
Oh.
in Alaska and BC.
Oh, I see. Yukon, okay. No, that's even more confused. Okay, well, no matter. Oh, I see. That's Koyukok. Okay, so you think the ones that have a, okay, totally weird.
All the ones that are it's in BC, you have Georgetown City,
What's that?
1101.1, Washington City, 1101.2.
Okay, so we think that this has a population of 95 people in 2015. Okay, well, there it is. It's a slightly obscure place. Oh, it's in the county of Yukon-Koyukok census area. I wonder whether this has the FIPS information. No notable people born in Koyukok. Maybe nobody's ever been born there. Okay, in any case, so look, the basic bottom line is these FIPS codes with dots in them. Do we think they're obsolete FIPS codes?
Yeah, it looks like that, yeah.
It looks like obsolete FIPS codes?
They used to exist.
Well, Lincoln, Nebraska, 31083. Okay, so I wonder what we do with that. So we probably have to say in the data, what's the most useful thing for us to do?
Patents were actually filed once they existed, but they don't exist anymore.
Yeah, right. So I mean, the question is, in the final data, what will be the most useful thing for us to put in there? Yeah, right. Well, but the thing is that if somebody's going to analyze the whole data set, they're going to have some stuff with dots in and some stuff without dots in. So it may be better, we've either got to map these into modern FIPS codes, or we've got to say missing, FIPS code doesn't exist anymore. Because this is not going to be useful, because if one's trying to map these onto FIPS codes, unless there's it's not going to work. I'm also not clear that the FIPS codes are all that useful to begin with. Let's take a look at how our job that was running the how our thing that was running the let's see, where was it? Where we did the cloud. Okay, so that's clearly wrong because it's got stuff in there that was decimal. What happened to our place where we were running? There we go, there's the cloud object. Still running. Okay, no matter. Okay, all right, so let's go back over here. So the FIPS codes, there's some wonkiness in the FIPS codes. There's some wonkiness in the counties because there are counties that don't exist anymore. What we probably can do is we can probably get an effective geoposition for these things, or at least an approximate geoposition. So let's assemble the list of what we actually want to be in the final after conversion. Okay, so wait a minute. Okay, so let's try to organize this a little bit. So let's try to organize what we want the final thing to look like. So someplace here we've got, where was our converter function? Let's look for that. Okay, so this is converter function. And now what we want to say here is, well, this is going to be code. And then let's say final desired form. So what we want there, I reckon, is we want a patent number. We want a year. We want a state. Again, it really confuses me what happens to patents that were from people who were outside the US. And actually, okay, so now we've also got questions here. What about patents from people outside the US? And another question we've got here is, what should we do about obsolete FIPS codes? Okay, so we got patent number, year, state. We've got we want some kind of approximate location because that's going to be useful, even though we're not going to be able to get the exact location because we've only got the county. In the patent, there's probably, well, so we can at least say county location, and that will be a geolocation, a geoposition. Okay, then we also have county, and we have data. We have data certainty is another one of those fields. I'm not quite sure what form that should have. And now let's take a look at what other fields there were there. the source. Automatically inputted locations. Okay. And we've got this FIPS code thing. Okay, so let's see. With the source here, we've got these things, MCS, MCU, etc. So let's... okay, so this one here, this alpha, is something where we say, let's call that, okay, error probability, something like that. And that's going to be, let's see, oops. So we can do, so what that is, means that you should expect for every 100 patents. So that means it's that divided by 100. So the error probability, we can compute, so we can give an error probability. And now what was the other thing was that way that it was entered. So that was up here, and that was this manually collected, manually contributed, automatically input. Not quite sure what the difference between step 2 and step 3 is. Okay, so let's go down here and let's say input method or data source method. And then we should say there it's going to be something like the possible source methods are going to be something like manual collection, manually collected, or we're going to say probably or manually contributed, or automatically input. And those would be and we don't know what the difference between step 2 and step 3 is. Anybody know what that, so, okay, so that will be, that's what we'll map the thing that says source method to. So data certainty is probably not what we want. We want error probability and source method. And the only thing missing here now is this FIPS code thing. Actually, if we wanted to, we might be able to pick up automatically from some patent API, we might be able to pick up the title of the patent, which would be kind of fun. But this will give us, hopefully when this thing has run, I'm surprised it hasn't finished yet, but still running. Okay. I think we should be able to tell it. I'm surprised it didn't record. Oh, I see. It went to the cloud, so it's not showing us what is. It's just showing us in this thing what's running. Okay. Well, a little frustrating here. We should have been able to get a little bit further here. I kind of feel like we might want to wrap up on this this particular curation effort, and maybe because what we've got to do is we've got to map. I mean, what I'd like to be able to do is to get to the point where we are actually submitting a data resource. So this will be, assuming that this can actually load it in. There we go. So this is a data resource definition notebook. And so what we would want to do here is say the goal here would be to get this the name of this thing would probably be, well, let's take a look at what the original thing was. What is it called? What is the original data set called? The histpat. What is it? geography of historical patents. So, I mean, roughly this would be called, we would want to call this historical US patent locations, maybe. But we might want to, since the database seems to have a name, HistPat, historical US patent locations. And the one-line description would be okay. I don't know why this is saying okay, so this, let me just store this someplace here. HistPat, we'll say it's our data resource notebook. So then what we would want to say here is something like inferred locations for patents, for US patents from inferred locations of inventors for US patents from 1790 to 1975. I don't really understand how this data set quite was derived, because a given patent will have multiple inventors which may have different locations. So I'm not quite sure how that works. Okay. Oh, it says it can be merged easily with post-1975 USPTO digital patent data to extend it to today. So that might be an interesting thing to do. Okay, so that's a separate issue. Well, now, okay. Well, anyway, we fill in the details here, and then we would fill in here, we actually fill in the content of the data set, and then we can upload this notebook, and then it will turn into a nice data repository entry. But first we actually have to have the data, and that's still a little bit more work here. And I think we should probably wrap it up for this, unless somebody has a brilliant idea for how to make further progress easily on what we have. I think this is, I think we probably have gone about as far as we can go quickly here. Let's just see. Let's go back to our, whoops, let's go back wherever it was to our thing here. Let's just see how it's doing. Still just running. Still just running. Okay. Okay. Well, I think we should wrap it up for now, and hopefully this this can get finished and uploaded. So anybody watching on Twitch, see you later.